Hello everyone, I'm Greg Karlovitz from the Hydrologic Engineering Center. Welcome to our course on statistical methods in hydrology. This video is part 3 of 3 on the topic of exploratory data analysis, and we'll discuss questions you should ask of your data when performing a data analysis. Let's get started. When starting out in an analysis, there's typically some kind of deliverable in mind at the end that might be used for further analysis or for making a decision. However, it can be tricky to decide where to start. The tools that we have seen previously in the rest of this discussion of exploratory data analysis help us answer all of these questions. We will look at these questions in more detail. We've talked a lot about the importance of visualizing your data. Choosing the right visualization for the data you've collected is important. By looking at the data, we could start to formulate hypotheses about what created the data that we have. The notion of a typical value gives us an idea of where most of the data points are, and also serves as a baseline for evaluating if an observation seems unusually large or small. Start by looking at measures of central tendency. If you compare regular and robust measures of central tendency, and they have very different values, then you might have outliers. Dispersion measures tell you how much variation to expect in the data relative to a typical value. Again, compare both regular and robust measures of dispersion to see if outliers are affecting your estimate. Both central tendency and dispersion are easy to see in histograms and density plots and are good visualizations for identifying these properties of a sample. Variation in the data is often what we're trying to explain. If every value was the same, it probably wouldn't be very interesting. We are often interested in seeing how and why these data vary. Using visualizations like the histogram and density plot can show how frequently data fall in what ranges and how much variation the data contain relative to a typical value. Some other visualizations call out values explicitly so that outliers or other data distant from the rest are clear to see, such as box plots, empirical CDFs, and quantile plots. Measures of dispersion and an asymmetry quantify how much spread the data have from the center and if there's a tendency for values to be more extreme in one direction, high or low, than the other. Usually, we're in the business of constructing models for our data, and we need to evaluate which models might work best for our data set. Before we start modeling, we need to make sure that the assumptions we usually make are going to be valid. The for plot helps us identify trouble spots before we start the modeling process. Once we've confirmed that the data are somewhat well behaved, we can use QQ plots to identify which candidate probability distributions might model our sample the best. In situations where we want to measure changes or see differences, we often want to compare two sets of data. The first place to start is with measures of central tendency, which give us an idea of how different typical values of the two data sets might be. If these values are very different, then dimensionless measures of dispersion are more informative about the variation in the data sets. We can overlap the same types of plots for the two data sets, for example histograms and densities, to visualize the differences in the data sets. Box plots summarize the frequency information about the data sets and can be used in a side-by-side comparison. Finally, scatter plots can give us an idea if the data are related in some way. The idea of a single population creating our sample becomes very important later on when we are constructing models for extremes. We want to check to make sure our sample comes from one population, and if it doesn't, that we can handle it appropriately. Run sequence and time series plots can show us if changes are happening systematically to the central tendency and dispersion of the data. We can also look at histograms and density plots for multimodal behavior, which may not be well represented in summary statistics. Independence in the data is important because dependent data require special treatment. The run sequence plot can show us periodic behavior in the data. The lag plot gives us a concrete idea of how strong the relationship between subsequent data values can be. In this short video, we discussed the questions you should ask of your data when performing a data analysis. 2 key points to take away from this video are: before starting a data analysis, ask your data some questions that will help guide you through your analysis, and rely on the exploratory data analysis tools we covered previously to answer those questions. Thanks, and come back soon to learn about other topics in our Statistical Methods in Hydrology course.